I want to take some time before we dive into the third part, which is actual Sparc stuff, actual Sparc code. So at the moment, we're trying to fix something in the demo that went wrong. So I'll take some time to answer some questions you guys had last class. If there are any concepts you guys would like to go over, I will do that. And then I'll also dive into a little bit of the theory first. So anyone have any questions about MapReduce, shuffles, DAGs, data frames, yarn, Hadoop file systems? Did everyone understand the points we made last time? Was it because of the onion analogy? Was it good? Was it? Yeah, so, okay. I'm going to do a recap, but I'm just going to, before I do a recap, I just wanted to see if there were specific questions that you guys didn't understand. No? Otherwise, all good? Okay, so I'm going to do a quick recap. Last time we discussed a couple things. We discussed the Hadoop system. Okay. True or false? If I say the current Hadoop system includes a parallel processing mechanism. True or false? Currently. Parallel processing? Does it actually do computations? Does Hadoop do computations? No. No, right? Okay, good. So Hadoop currently Hadoop is just two things. One is it's a file system, so it's called an HDFS. And the file system is basically this is just a file system. And we have something called yarn, which sits on top of the file system, and it's called yet another resource manager, or resource negotiator, I guess. And yarn just handles scheduling. So when I say scheduling, it determines which cores go where, how many cores get how much memory, what kind of processes goes where. So it's basically kind of like the boss of things. So yarn does the scheduling. So, and then we talked about Sparc. Okay. So I'm just going to go over the structure first, and then basically the structure is at the very bottom sits HDFS, which are the files, the actual files. On top of that sits yarn. And Sparc sits on top of yarn and interacts with the yarn scheduler and does its parallel computations. So we're going with this specific configuration because we want to work with Sparc on a Hadoop object. And I'm going to actually explain why it may or may not be important. So that was the structure of the, everyone gets this, right? I think this was pretty clear last time. And we mentioned that so we went into Sparc. But even before we went into Sparc, we talked about a specific concept called MapReduce, right? And we mentioned two things: what MapReduce is, and two, what the MapReduce shuffle is. Okay, so who can explain to me what MapReduce is? So what are the two parts in MapReduce? That's pretty simple. Okay, mapping and reduce. Yes, thank you. So the hard part is actually the MapReduce shuffle. So I want to see if everyone understood what MapReduce is. A MapReduce shuffle is. Does anyone remember? Oh, no. Does anyone remember what MapReduce shuffle is? This time I'm going to ask you a lot of questions. Remember what the MapReduce shuffle is? It's a very simple thing in terms of what it is. Anyone? Where's Luca? Luca, tell us. What is it?
Well, I don't fully remember.
So you don't have to explain what the mechanism is, but what really is MapReduce shuffle?
Wasn't it the direct acyclic graph?
That's the first one. Okay. I see that there is a need to explain MapReduce shuffle a little bit again. So MapReduce shuffle is really just a simple transfer of information from mappers to reducers. That's it. So in MapReduce, let's say we have 4 blocks or 4 partitions of data that we want to parallelize our operations on. So at most we can parallelize what? Over 4 different cores, right? So let's say I have 3 mappers. Oh, sorry. Let's say I have 2 mappers and 2 reducers. For some reason, let's do 5. I just want more mappers and reducers. Then each task is sent to mappers, maybe these 2 weights, and then these get shuffled, right? So why is this? So the MapReduce shuffle is a very costly operation in all of parallel processing, because this is actually a scheduling problem. There are usually less reducers than mappers in the system, and there are complications involved with reducers. Reducers could be within the server. So let's say a mapper just finished a task. Where do I send the task to? Like, which reducer do I send it to? It could be a reducer that is currently working on something else, but could be freed up, that's closer, or reducers that are farther away, but are relatively easier to reach. Is that clear? Okay. Yeah?
Wait, none of this is on the same server, like normally distributed to multiple servers, right?
So the whole, it could be on the same server or not. So like I said last time, I talked about there are two situations, right? Let's say a mapper just finished here. A mapper just finished. Its task was to get a partition and then count some words or sort whatever it was. It did some kind of iterative operation. After it's done, it's like, okay, where do I need to send my thing to get reduced? And let's say I have a reducer here, I have a reducer here.
Yeah, but one.
This one's occupied, this one's free. But it could be the other way. In which case, if this is free, and this is not free, obviously the better choice is to reduce here. But usually the complication then is like, usually I'm not the only one that has finished. So which one goes first? Or which task goes first? And basically that's why there's a shuffle, right? Once mappers are sort of done, or starting to get done, we assume that mappers generally finish in a similar time scale. And once they're starting to get finished, how do you send what to where? And during that process, this is a very costly process because one, it's a scheduling problem, and second, because it does what? What do you have to do every time you map reduce shuffle? Come on, guys.
Oh, right to the. You have to write to your disk.
Yeah, not write to memory, write to disk. It's different. Memory is closer to, memory is closer to the servers. You can easily parallelize. Disk, but it's more volatile, so you need to save it somewhere, which is the disk space, to back it up. Right? Every time you need to shuffle, you need to first write to the disk. So this whole very costly operation is something that we want to do the least amount of time as possible. Right? But in MapReduce, in traditional MapReduce, we don't really care about this kind of optimization. We always just did a MapReduce shuffle whenever a mapper finished and has to send it to a reducer, you have to solve a MapReduce shuffle problem. Does that make sense? Okay. Is that clear? This should, we went over this quite extensively last time, so if you don't understand it, you should come and ask me questions. Okay? I'm going to go really a lot faster than I did last time. And then we talked about 2 things. We talked about what Sparc does to make this better. One is a DAG, and 2 is a data frame. And what does a DAG do? What does DAG stand for again? Directed acyclic graph. So basically, I'm going to give you an example of a graph. That's a DAG. It's directed. It's acyclic, so you can't come to the original node again. And it's a graph. There are nodes and edges. And this is a good representation of some kind of parallel operation, because in a parallel operation, you're not supposed to come back to where you were in any stage. And you have a clear direction of workflow. You start, you end, you have a product. And what Sparc does is it draws a DAG, and identifies clumps within the DAG that you can group together and have the entire group wait until everything in this clump finishes before doing a map reshuffle. So before, maybe you have to do a map reshuffle here at this stage, so you have to do 2 map reshuffles, but Sparc solves a DAG problem and sees that the map reduce doesn't really need to happen until at the very end, because the processes here don't necessarily depend on each other, for example. Right? That makes sense? Yes. So that's a very hand-wavy thing about DAG. So I said, basically the operation that Sparc does is it just, when you give it a bunch of things to do, it first constructs, even before actually doing the tasks, it creates a directed acyclic graph. It finds which operations can be done together before doing a map reshuffle, such that map reshuffles occur at a minimum. You want to minimize the number of times map reshuffles happen, just because map reshuffles are just egregiously slow, right? It might not make sense in a purely logical sense because you're kind of making things sequential. You're like waiting for things like, for example, this node might have to wait for this node to finish before doing a map reshuffle, and it might not make sense logically that this is a better parallel operation, but it's just because the map reshuffle is a horrible operation. That makes sense, right? So if we do 2 instead of 3, it's good. If we do 1 instead of 3, that's wonderful. And the data frame was just another layer on top of that, such that if you know that your data set can be organized into some kind of chart format where you have columns, you have rows, then there are basic things that you can optimize even before constructing this DAG. For example, dropping columns that are not needed when you're doing joins. In general, making the objects that you're working with smaller than is as small as possible before you operate on them. So stuff like that. So I'm going to just hand wave this and say query optimization. Right? Every time you pass off some kind of operation, if you have it in a chart format rather than an unorganized format, it's actually fast. You can actually make things a lot faster because there are tricks you can do. So Sparc does both a DAG operation. These are more for traditional RDDs. So I'm like dumping out info, but you guys should already be familiar with it. So there are 2 objects in Sparc: data frames and RDDs. RDD just works predominantly just with DAGs, and data frames use both. It first creates a query optimization plan, optimizes your operations so like that your objects that you have to handle are smaller. Then it constructs a DAG, minimizes the number of times you have to do a map reshuffle, then does it. That make sense? Yeah.
So in the DAG, how do you know which is a map reshuffle? Is it the one that has like a lot of nodes going to it, or is it just...
So map reshuffle, like, so for example, I'll give you an example. Like, it's hard to think of it in terms of like that. It's not like a claim like, okay, I'm just gonna do it here, but so for example, let's say I'm sorting, right? I'm sorting, and I have 5 partitions, and each of my partitions are independently sorting each other, right? And the tasks that each are doing, so the data set that each is handling, has nothing to do with each other, right? So, but then maybe, let's say these finish really uneven. Make sense? Like, this finishes in like 2 minutes, this one finishes 5, 4, 10, whatever it is.
They're sorting, right?
Yeah, we're sorting, but like, they have some kind of varying degrees of completion time. You might think originally that, or in the strictest sense, it might be better to just feed them into a shuffle, sequentially. You know what I mean? Like, if this thing takes 10 minutes, you probably shouldn't wait for everything to finish for 10 minutes. But, and I'm exaggerating here, it's not going to be as different as like 10 minutes and 2 minutes. But basically the idea is, in order to reduce the map reshuffle, you can make everything wait before everything finishes, and then do a map reshuffle, like once, rather than have it as a continuous process of map reshuffle. Because every time you need to solve a new problem, every time if it gets drawn out, it's more difficult of a scheduling problem. Once you assume everything is done and schedule, it's easier. Does that make sense?
Yeah. And in the DAG, what are the nodes represented? Are they just the tasks?
Processes. So stages, you think about them as like, yeah, so this gets, so in the actual DAG, this gets grouped as one node. Because this is a map, so it's called usually a map partition operation. It means like you're mapping the partitions. Make sense? So this would be like a stage. Like, not stage, but this would be like a node in the DAG. Okay? But obviously, so because of this reason, because like you can simplify many things as the same things, like these are all same things, so they get grouped into one node. Your DAG will, the actual DAGs that Sparc generates will be very simple. Like it's nothing. It's just like one line. It just looks like a one-dimensional flowchart. But but sometimes you also get, you know, things getting divided into two. Right? Maybe your processes need to do different things that depend on each other. So is that clear? I just blitzed through the second lecture. Okay. Because I had someone come like 2 days ago and said, no, they didn't understand. You know, they got really lost like 1/3 of the way through. And they didn't understand, so I explained for a good 20 minutes. But it's a difficult concept, I understand. So if you have any questions, please don't hesitate to ask. Like, it could be like anything that's really stupid. I mean, I'm not saying it's stupid, but like it could sound stupid, but it's actually a very important thing. Because a lot of times, things that look simple, like parallelizing, it would seem very easy, like chopping things into 100 things and then distributing. But even that, and in like an actual architecture sense, is a difficult operation. Like it's not a simple operation. So if you have questions, it's usually perfect. So we said this. We said that it's a Taylor Swift, and everyone laughed. Yeah, it's a. I had to look at this again. I had some doubts, and I had some remorse thinking about comparing software to Taylor Swift, but it's okay. It was all Nolan.
No.
Okay. Can you, if it's done, can you upload it? Please make sure you are logged onto the Slack that we shared, just because we're going to be uploading things for you to actually look at. I already shared a CSV file that we're going to be using as an actual demo object. Okay. So I'm going to go with the assumption that you guys all have Sparc and Hadoop. If you don't have it and are lost, we'll try to help you guys out individually. But for the most part, I'll just assume that you guys already have it. Are you guys also all on Linux right now? Cool? Cool, okay. Everyone's downloaded the green.csv? Oh, actually, Nolan had this idea. You want to have everyone do it? Paper? More than 3? Okay. All right. So we're originally we're gonna have you guys all fold pieces of paper and like into a triangle shape and like put it on your tables so that when you're done you can put it down and I know you guys are done. But and this like the Taylor Swift anyway, so the bottom line is when you are done, like I say do this. And you are done. Please indicate that you are done with a nod. When I say, "Are you guys done?" then you like nod. Like nod. This is.
Should it be if you're not done, do something?
Or if you're not done, do something. If I ask, "Are you done?" nod. If I ask, "Is anyone not done?" raise your hands rather than do this. It doesn't really help. Okay. This is supposed to be an interactive sort of workshop, so please keep that in mind. Okay. Everyone has the green.csv, right? If you download it in Linux, usually it should be in the downloads folder. Is that right? Okay. Also, I'm going to assume that most of you don't know Linux commands. Okay? Okay. Here, give me a second here. everyone see this? Yes? Not? We're going to practice the nodding thing. Okay, so go to downloads.
Oh, Canon did this thing in the installation guide that like moves people's downloads folder somewhere else. So some people's downloads folder is somewhere bizarre.
Okay, who has this problem of not having a download?
If your downloads folder isn't there, go to user local Hadoop, I think, and then like backslash user or slash user slash local slash Hadoop, and then look for your downloads folder. It might be in there. This is Cameron's fault, not mine. Or it could be in user local Sparc. It's in one of user local Sparc or Hadoop.
Okay, so before
before
this, okay, wait, just one sec. So thank you for the heads up. So I'm going to do basic Hadoop commands, or not Hadoop commands, but Unix commands that will help everyone. CD is the thing to move to a directory. Okay? So if you want to go to user local Hadoop, you do CD user local Hadoop. Change directory, yes. Ooh, nice. Nice English skills. Okay, is it there? Is your downloads folder there?
do ls and see if downloads goes up.
Do ls? Is downloads there? I apologize for Cameron's fault.
I can go through the installation.
Okay,
I'll find
Can you
where it
go
should
and help
be.
me? Can you go and help me?
Yeah, I'll find
Okay,
where
so
it
we're
should
just gonna move on. Okay.
be. Yeah, I know because I did it to you and.
Okay, so CD downloads.
Last week.
Okay, so you have something called green.csv, correct? Everyone has green.csv. So, and we did an exercise where we put our files into the Hadoop distributed file system, right? First of all, everyone do JPS. Does everyone see this? Everyone sees this. JPS? Okay? So, you should have a resource manager, a node manager, a secondary name node, or data node. If you don't have, so if you have only JPS, that means you didn't start it. So I'm going to do the command that Cameron hates. Start all dot sh. Okay? If everyone does it, okay, if you already have things in JPS, don't do this. Because you're starting a thing that you already started. Don't do that.
Does stuff still download into the download folder even if it's not in like downloads?
I don't know.
I don't think it does.
I think you can control where it downloads.
I found the download folder. I know where it is, but nothing's in it.
Okay, just move it back. Move it back. Just move it back. Okay.
Wait, where is it originally? Like just
It's a hole, so tilde. Just do tilde.
Tilde slash.
Tilde slash. Okay, is everyone good with this?
Find your download. So if you go to like your web browser and then go to your downloads and click on your download history, you can just right click on the file and say open containing folder to find your.
Oh, okay, yeah, that works too. Wait, you can do open in folder like for on Slack.
Yeah, it'll just download with the
Okay.
browser.
Okay, let's organize this. Okay, we're gonna if individual problems come up, Nolan, can you also help if I'll definitely. Okay, yeah.
Yeah, so you can start off.
Yeah, no,
I have everything except the.
that doesn't work.
Name node? If you don't have name node,
That's fine.
if you don't have name node,
There's no way it works.
okay.
I'll just
So,
do
if you have
where did you want to move the green.csv?
Yeah, I have everything except.
you don't have to. You just need to find it.
You just need to find it?
Yeah.
Oh, okay.
You found it?
Okay, yeah, I found it.
Okay.
Do the format.
Okay. So, all right, you gotta keep focused. So, if you have questions, please put them. I'll post them on Slack. And I'll try to individually send people. You can also raise your hands and then like look really like panicky, and I'll like designate either Yuji or Nolan to go help you. Okay? Choose your own panicky face. It's fine. Okay. Okay. So stop everything if you don't have name node. Stop everything. Okay. What you're gonna do next is, I believe if you went through our guide, it should be fine. So you should do HDFS name node dash format.
What is that doing?
What's that?
What is that original?
So this basically reconstructs your entire HDFS. So if you have files that are valuable that you've already put into HDFS because you're like amazing, and you wanted to use HDFS for some reason, it will delete it. So like if you're like a data scientist at like Microsoft and they store all their things in like HDFS and you had like sudo access and you wanted to name node format because your name node is missing, don't. That is not a good idea. But you guys get the basic idea.
What exactly is name node in terms of like what we've learned right now?
Name node is basically the head, the master of the file system.
Oh, it's the resource.
It's name node is the thing that keeps track of where things are.
What was the term for application manager or resource manager, right?
No, name node is just the file system. Resource manager is a yarn.
Oh.
So like if you go back to your like the pyramid or whatever, then like on your master sits the resource
Okay.
manager.
So
and
after you do HDFS name node format, do start all again. So start all.sh, and you guys should probably see the name node. Okay, so I'm just gonna skip over that now. Okay, so try that. If that fails, let me know.
What was the command to check again?
Check JPS. So I'm gonna start all. Actually, I'm gonna go into the CDS servers. Okay. So I have something called green.csv in the directory right now. You guys should be at the on the terminal. If you type ls, you should see green.csv. Does everyone have green.csv? Correct. Okay. Cool. Okay, so we're gonna do Hadoop. So last time we created a text file and then uploaded it into the HDFS, right? We're gonna do something we're gonna do the same thing without creating something. So we're gonna do Hadoop, fs, mkdir, so make directory, and then we're gonna call this what? Let's call it demo. Okay? So try to follow this. Okay. Okay, and then in Hadoop, fs, put. So every time you do something with the Hadoop distributed file system, you're going to be using the Hadoop fs command. It basically stands for Hadoop file system. Yes?
Warning.
Warnings don't matter in Hadoop. If you get a warning,
In general.
just in general, a warning is like, stop, you're doing something like too technical. And they're like, and you're just going to say, I am technical, and I'm doing it.
Is this unable to load native Hadoop library?
Yeah. So that's also fine. Does it say warning? Does it say warning in front of it? Yeah, if it says warning in front of it, it means everything is fine. That's what warning usually stands for, okay? For the sake of Hadoop. Sorry, so we're going to put, granted that when you type ls that you see green.csv, you're going to put the green.csv file into the Hadoop distributed file system. So what do? You put it in demo. Okay? This directory doesn't exist anywhere outside the Hadoop distributed file system. So if you actually want to find demo in your natural Linux environment, it won't exist. But we're putting it in demo.
So wait, question. Why does it give you the warning? I know it's fine.
Because you can actually define the way Hadoop runs by actually defining some jar files and then directing Hadoop to there. So Hadoop is just telling you that it's not following any other protocol, it's following the default protocol. So that's why it's giving you a warning, basically saying everything is working very fine. Okay, yep.
Well, every time I'm trying to start, that connection it says connection refused.
Oh, if your connection is refused, try to reinstall OpenSSH server. So sudo apt remove OpenSSH server. Sudo apt, and then sudo apt install OpenSSH server. And then in the installation guide, there's a specific cell that starts with SSH keygen. So try to find that. So in general, when I'm typing these things, I can't like stay on each command like for 2 minutes. So if I type something, try to type it down somewhere in an open notepad. Yes?
What's in the data node? GPS.
Okay. So question. if your data node is missing, if this is missing, remove var lib Hadoop HDFS name data node. Okay, you can do word for word what I just typed in. It was just copy and paste it, and then do the name node reformatting after turning everything off. Remember always, if you're formatting the name node, you have to turn it off. Okay. Okay, is everyone good? Okay, usually I see you like 4 times a week, so you should be able to work it out. Usually just go
Go
to
to the server.
that works.
Do it on the server. Yeah, but then you're doing it on the server.
I mean, you won't actually run the code.
Oh, wait.
Just turn it off. Okay.
Stop.
Okay. So now Hadoop. So I said ls is the command to show all the things in that directory, right? Right. So it's like list files, right? And then I can do the same thing in Hadoop fs command. So Hadoop fs is basically just like telling your terminal that you're not working under the normal Linux directory system. You want to look at the HDFS specifically by saying Hadoop fs. But most commands in Linux or Unix translates over to Hadoop fs commands. So like Hadoop fs ls demo should show you the content of the file in the demo. So there's now a file called demo.green.csv. That make sense? All right. Did you upload? Can also people download the IPython notebook that was uploaded onto the Slack while you're at that? Okay. This is going to be a little painstakingly slow, but we want you to be able to do this properly. Okay. So before I even have important files, I want you guys to know the important ports. Okay. So important ports, yarn is 8088. So in general, when you want to access ports, you say something like localhost :8088. Localhost :50070. Okay. That question you just put just now has a warning in front of it. What do I say warning means? Everything is just fine. Okay? Please remember, everything is just fine. Usually this is not the case. Don't do that. But 50070 is the name node. So have both up in the browser. Okay? So localhost 5. I don't have anything running. I don't actually have Hadoop running at the background at the moment. So type that. So localhost : 50070. Does everyone get this screen in your browser? Okay. Okay, cool. I see 2 people nodded. Everyone nodded. Okay, cool. Do people not see this? Who doesn't see this? Oh, that's because you don't have a name node, right? Okay. Other than your laptop is giving up. Okay, everyone sees this? So the Hadoop fs-ls command. Did everyone do that and see the same thing I did? So Hadoop fs ls demo. So the demo is the thing that I created. I also put the green.csv file there. Yes? What was that? Oh, you see 3 things in there?
Yeah, that happens to me. Or actually,
Oh, someone's taking it as I look at it, so it's not fun. Okay.
solve that problem.
So wait. I'm trying to. So remove everything in the directory by doing Hadoop fs-rm /demo/star. Just people who has the error. Don't do this. Yep.
When I tried to put it in, it said
it should be Hadoop fs dash put. Yeah. Yeah. When I type a dash, it's not for decoration. You have to put the
I
dash.
put dash put and it says that that's not a. Oh, but I didn't put it.
Yeah.
What's the second URL we have to open? Localhost 570 and what's the second?
8088.
Localhost
8088. Who is fine? Who's okay? Okay. Alright. Most people. Okay. Okay. So try to remove the contents and do the same thing again. Make sense? So Hadoop, I did 3 commands. I created demo. So I did these 2 things, right? So make sure you do that. And in order to check whether it's working, I did Hadoop fs ls green.csv. Or sorry, Hadoop fs demo, because I wanted to look at the demo. Does that make sense? Okay. Did you also reformat the name then?
No.
To do that.
You're just throwing shit.
Oh, what's up? This is what you should look at. Wait, Chan plan? What is your question? Format and start. Okay. I'll come to me a little later, and I'll help type that. Actually, Nolan, can you? I don't know what. Okay.
It still doesn't work.
We'll figure it out. Okay, so the same thing I did as an ls command is I can do the same thing in browse file system. And I have a thing called demo that I created, and if I go in there, I can see that this file has 227 megabytes, and it has 5 replications. So this means that this is stored in 5 blocks. Or sorry, not 5 blocks. It basically means that your files are replicated 5 times and stored across the different servers. Does that make sense? Okay. I also told you to go to 8088. And you would actually get something, yeah. You will get something like this.
You should have that no data.
What was that?
You should have no data, right?
And you should have nothing. This is because I've been running stuff. And apparently someone is already still running stuff. Wait. Is someone running the... Nolan, can I kill your application?
Yeah.
Okay, so I'm now going to exercise my superior capabilities and kill an application with no consent. Now it has died. Okay. Okay, so so I'm going to do I'm going to talk a little bit about the theory a little first before we actually dive in. I'm going to assume that everyone, besides the ones that didn't work, with a few of you, and I will attend to you individually, but that you guys can actually...
Is this uploaded onto the slide?
Yeah, it's on
The slide?
Oh,
yeah, I'll do that.
Yeah, I saw the...
Anyone with a link.
Are you talking about the
can view. You don't want people like, okay. Okay. Okay, I also uploaded the docs, so please look at it. Okay. So in general, we said last time that it's really hard to find information on Sparc online, but that's actually only partly true. What we really tried to say was the actual mechanism, the back-end mechanism behind Sparc, like so things about DAG, things about query optimization, things about data frame APIs, so that kind of stuff is not very well documented online. But the actual syntax for what you can code in PySpark is documented quite well. So for example, if I click on the PySpark documentation, which we'll be using, there's a whole bunch of stuff here. So basically the entire module is here. Fortunately, the reason why, so to give you a little fun aside, I used to work in R, and R also has a Sparc API, and the list basically stops somewhere in like the 6th line. The amount of functionalities that are offered currently, at least. It got updated like last month into like 12 things. Now there's like, as you can see, Python is very popular in the tech industry. They do a lot of GitHub commits, and now they have a lot of functionality. So I switched over to PySpark. So, but those of you who are R users out there that are still garnering hope, do not worry. There is Sparc R. Also, there is the general Sparc documentation. Okay, so I want to talk about why we're using Sparc on Yarn. Is because Hadoop has very good properties that really allow good data engineering. So we talked about last time that Hadoop stores stores files in very large blocks, and those large blocks allow really high throughput of information. So rather than lookups, Hadoop basically forgoes good latency, forgoes quick lookups entirely in order to have massive throughput rates in the data cost. So Hadoop itself is a very good database to use for parallel processing. And two, Hadoop is also an unstructured, NoSQL database. So whenever I say NoSQL, I mean it handles data sets that are not in clear chart format. So things like MongoDB is a good example of a NoSQL database. Hadoop is also a NoSQL database because it can handle anything. It can literally handle anything because all HDFS is, it just chops files up, figures out where the files are chopped up. And the files that are chopped up themselves don't have to necessarily be charts. So since Hadoop is a really good thing to use, we want Sparc to work with Hadoop. And even though Sparc has its own scheduler and therefore can run independently, we want Sparc to interact with Yarn so that it's able to effectively schedule things on the Hadoop system. So you're going to do this repeatedly. So PySparc, if you do PySparc, this pops up, right? Everyone should have this popping up, right? So PySparc by itself, when I say PySparc, this is actually a standalone mode. PySparc is just on its own. It has its own scheduler. It's usually also running only on the server that you're running because Sparc on its own, PySparc on its own doesn't have any information about the file system or the cluster. So it's usually running only on one server and it's therefore not really parallelized. But at the same time, you can do this. So you can escape the state by doing Control-C. And Control-C is just, so keep writing this down in a separate notepad if you have it. Control-C in any terminal operation means finish. Just kill whatever you're doing. And on Jupyter, when you do that on the Jupyter screen, it asks you, do you want to terminate? And you can just ignore and just do Control-C again, and it will just kill it. Okay? Yep.
Just open the new Jupyter notebook and for PySparc.
Yes.
Oh.
Yes. The installation guide that we gave with the tar files and everything, we explicitly made it sure that you automatically start Jupyter if you will start PySparc. Okay? So instead of just PySparc, what you can do is tell it what to interact with. And that's basically you're telling it what master is. So don't press enter yet. And I'm going to tell it to use yarn. Okay? And I'm going to do an additional thing called deploy mode client. Can everybody do this? So remember to do all the dashes that I'm putting in. PySparc, -- master, yarn, -- deploy mode, deploy - mode, client. I'm going to explain what that client part means and also explain, so I've already explained what that master yarn thing means, right? You're telling PySparc to work with yarn. And yarn is, it's basically telling PySparc that yarn will be your boss. And now it's like under boss yarn, negotiating. Now it doesn't have any freebies, so it just has to work with yarn. The deploy mode is actually an interesting point. This is kind of not essential to know. So what the deploy mode is, there are two types of deploy modes. One is client. The other is cluster. And I think if you do cluster instead of client there, it will throw you an error. Okay? So what client is if you have a server, you're basically your application master sits inside the server. So your servers are constantly communicating with the application master that's on the same server or same cluster. So it's part of the system that you're running. That's what client is. And cluster is basically you have a remote laptop, and mine's like cracked because my cat dropped it. You know? And it actually has a huge cracks. But anyways, and then it interacts.
Unless your cat picked it up.
Yeah. What was that?
Did your cat dropped it?
Yeah. Last night, cat dropped my laptop. It fell like.
How does your cat pick up your laptop?
You mean push
No,
it?
it's on the. Yeah, it got pushed.
Oh, okay.
No, the cat was like, oh yeah. It was actually using PySparc, but who knows? He basically he pushes the laptop out of the way. It's doing something. But anyway, and then it interacts remotely with the server. If the application master is not inside, but actually on a remote computer that you're using, and you're interacting with the cluster in this fashion, it's deploy mode cluster. But you guys don't need to worry about it. But if you're interested in knowing what this is, you can actually read it off on the document.
So client is that if it's stored on
If it's inside, you're part of the system. Yes, go on.
If you don't do PySparc -- master yarn and just do PySparc instead,
It's a standalone mode. You're not interacting with yarn at all.
Yeah.
Okay. So we're gonna kill this again. We're gonna like repeatedly start and kill, because I want you guys to be get used to the whole process. Okay. So even before I go anywhere, I want to look at the configuration files, right? So echo returns the value. So the command echo returns whatever you tell it to return after. Okay. So if I do echo s, it will give echo s. Echo long live CDS. It will give long live CDS. Okay. It just does the thing that you tell it to return. It also returns what is known as environment variables. So So if I say return, so I've defined Hadoop install somewhere, I've defined it in a system file such that if I refer to $Hadoop _ install, it automatically recognizes it as the directory in which your Hadoop files or Hadoop directory lies. And I believe I made sure that the installation guide was was made in such a way that you should get the same result. Hadoop install? Does everyone have it? Okay, you're a black sheep. Okay. So sorry, so I did CD, but echo should work too. So if I do echo Hadoop install, I should get the directory that corresponds to that environment variable. Does everyone get this? Okay? If I do echo Sparc home, I should get the Sparc directory for which I came from. Is that clear to everyone? So these are variables that are defined in the environment that you're working with already. And usually these are in a file called bash rc, but that's beside the point. I don't want to go too deep into bash. Okay, so what I'm going to do is I'm going to use the cd command as I did before. CD is what? Change directory, right? Okay, so before I do that, I want to talk a little bit about the cd command so that people don't get lost when they're in the wrong place. Let's say there's this folder called, I don't know, you don't have to follow this. Let's say there's a folder called Yelp over there, right? On the right. And I can go to that folder by typing Yelp, and it goes there because it exists in my directory. And I'm back here. Or what I can also do is I can go to the Yelp folder by defining the absolute path, so the absolute directory. So what that means is the actual address of that Yelp file is home, huser1. So you guys don't have these files, so you can't follow. And this also goes to the same thing. Okay, that makes sense? And there are two things you can do, or one thing that's actually quite useful. Let's say you want to move up a directory. So you know that like folders icon that you guys always click in your file explorers, and conveniently just goes up to the directory. In Linux, all you need to do is do cd dot dot, cd space dot dot. So the dot dot refers to the directory above. So have you guys tried like unzipping a file, and then sometimes like there's like this little thing on the top, like when you're unzipping a directory, and there's like this little thing on top and it says dot dot, and you guys always wonder what that is? That's what it means. It means directory above. Okay, so I'm gonna go to Hadoop install, cd Hadoop install, and I have all these Hadoop files. I'm gonna do cd $Hadoop install etc. Oh, sorry, wait, let me clear this up. Okay, cd $Hadoop underscore install, all caps, slash etc, so a folder inside the Hadoop directory called etc, and inside that I also have another folder called Hadoop. I don't know why. They have this structure, and inside that, when I list the files there, I get all these kind of stuff. Does everyone see this? Good? Okay, oh, thank you. You're like, everyone must follow his example. Okay, so a lot of those files here that are kind of like created for some reason, and I didn't delete it, but you guys should probably have a little bit less than this. There are some repetitions here, right? They're like temporary files that got created because like I opened it and didn't save, whatever, stuff like that. So we're gonna do vim or vi. So first of all, do vim. Does everyone have vim? Does everyone have vim? Sometimes you don't have vim.
How did you get to them?
You don't have vim. Press ESC. So for those of you who have vim, press ESC Shift ZZ. Okay. So press on the Shift Z. Okay. Right. Also, I found out the difference between WQ and ZZ, but I'm not going to go into that here. Yeah. Okay. So where was I? So if you don't have vim, do vi. Okay. Everyone should have vi. Okay. Vi yarn dash site XML.
Wait, I just installed Vim.
Then you can do the same thing vim. So vim yarn. Okay. So vim yarn dash site XML or vi yarn dash site XML. Either one that works. Okay. Okay. Does everyone see this?
Yes.
Okay, you can go down. Okay. Press Shift G and you can Okay. Shift G. Oh, I don't know what's going on.
Slow down.
Okay, so you guys all have this file, right? Are you guys in the file? Yes. Right.
As soon as you get started, you just.
You need to stop periodically, because as soon as you get stuck with something, you're instantly fucked, because you just keep going.
Okay. I'll try to type the commands I did into the Slack channel while I'm doing it so that you guys can follow along.
Whoever asked that question, the answer is escape, WQ, enter.
I just pressed a bunch of buttons and it closed down.
That also works.
Press Control X. Just press Control C. And like,
No, you can't do Control C.
I don't know, work at it, Control C.
It doesn't work always. Yes?
Is there a way that we can fuck up some text here that we can restore?
So, okay. So I'm gonna, this is gonna be extremely slow today, so it's fine. We're gonna go slow. But, VI has 2 modes, okay? 2 modes. Okay. Oh, that works too, yes. Where set that? Africa. Thank you. Anyways, when you do VI, the initial mode you enter into is called execution mode. This is your master execution mode. Nothing, if you type anything except like I, O, or whatever, usually it won't edit. And in order for you to edit, you have to change into your edit mode, which you can do by pressing I, because I stands for insert. Does that make sense? So I can like now, I obviously don't want to do this. What I can do is I can escape back into the execution mode, right? And how do I do that? I press ESC. I go into the execution mode. I can't edit anymore, but I can do U. And U is undo. So U is like undo. You can go back to the original state that you entered the edit mode in.
So this lets you Vim, that lets you interact with Sparc.
No, Vim is just a text editor. This is just a text editor, guys.
Oh, so this is where you put your type.
Yeah, you type or you, no, you don't, this is just like, I'm just trying to change or go into, trying to see the different configuration files, right? Okay, so the reason why I'm going into the yarn-site.xml, I said in a slide that it's important. Okay, 1 second.
Does anyone have any other issues?
Because of the arrows.
Oh, yeah. Don't like accidentally just press a bunch of arrows to type letters. Yeah, the first time I used Linux, I analyzed that.
So wait, don't use the arrows to slow down.
If you're in execution mode, if you press an arrow, just type
I'll do it too. Alright, what is your question?
How do you scroll it?
like you gotta be in a certain.
I guess it's Slack.
Or you can use Nano, but like, I like Vim. Vim is pretty popular. Or Emacs. Or Emacs, or Nano, or there's a whole bunch of text editors that you can use. Okay, so
Oh, you're just trying to see. Oh, yeah. So you just see CD etc.
Or just like stop it. It's not.
Oh, you just see the CD.
okay,
I don't have to be, I can be,
And then you see
all right, guys. So the reason why I go into yarn-site.xml is because Yarn. Okay. So Yarn basically. So whenever you want to, so is everyone good? Right. So Yarn. I just told PySparc. So PySparc is going to be running with Yarn, right? Yarn is the new boss. The Yarn dictates terms. So where you tell Yarn to dictate what kind of terms is actually the yarn-site.xml. Does that make sense? So like, how much memory can you actually dish out at a maximum? Like, if a server comes in to the master node and says, yo, I want 180 cores, then you're like, I'm allowed to only dish out 36. That's kind of like the thing. So you want to have some kind of configuration in the yarn-site.xml. So in the yarn-site.xml, so don't edit anything, just scroll down once you do the Vim. And there's like many different things. I've named my host name called master. A lot of these are actually repetitive. You don't need to write these, but I just did. Because at the time, this was in the winter when I was first installing, and I didn't have a workshop instructor to help me. I crashed my computer like a couple times. So this is the result of it's like the garbage part of DNA, like your history just kind of like piles up. This is completely unnecessary stuff, but. So for example, things that you can do is like you can tell the Yarn node manager, so Yarn has a resource manager in the master node and node manager in the slave node, right? You can tell how much memory to allocate to each node manager. So how much resources does each node manager get? You don't have to do this, but I'm telling you, you can tweak it like this. So the point of it today is not for you to actually edit this stuff, and the point of it is to tell you where you can edit stuff. So so usually what you do is you go online, you go to Google, and you say, how do I change this property? And it will give you the name of the property. So I actually had to search up this memory, how much memory. So for example, how much memory. So at a minimum, how much memory should Yarn dish out to everyone? And who comes to, or when I say everyone, it sounds like human. Whoever comes and requests some information or some resources. So that's yarn scheduler.minimum-allocation MB. So this is a name. So usually you look this up. And the format is you start with property with brackets or pointers. You define a name. And whenever you finish something, you always do an backslash. You tell Yarn what is being tweaked. So this configuration. You tell it how much to give. So that this is 5 gigabytes. So at a minimum, each node or each process gets 5 gigabytes of memory. Does that make sense? And then I finish the value, I finish the property. So it's usually, this is how you tweak. So there's not enough time in this session for me to actually go and have you guys change this manually, because usually you guys will do something wrong, and then it will crash. And would be very unfortunate. So we would not like to do that. So I'm just showing you that yarn-site.xml is where you tweak things. Okay? Okay, so now I'm going to go to CD.
Wait, how did you get out?
ESC goes into the execution mode, right?
It's the colon to
And then colon WQ.
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 You didn't bin, so it's just Q.
Oh, you can do Q. Or Shift ZZ works. Come on, guys. Shift ZZ.
If you can't get out of the file, just let me know and I will get you out of the file.
Yeah, so if you can't get out of the file, do ESC Shift ZZ. Hold the Shift. The Shift ZZ basically deletes the file if you haven't said anything. WQ doesn't delete it even if you have written nothing. That's the only difference. But Shift ZZ is fine, even though camera doesn't like it. It's fine. Okay, CD, Sparc, home. Okay? LS. So I am at the Sparc home. Now I go to CD. So I do it again. Sparc home, con. And in this place, you should have these things. For some of you, sometimes only the template or the copy exists, and not the actual file. Does anyone have that problem? Does everyone have a sparkends.sh, sparkdefaults.conf? Okay?
It's dot template.
Okay, so what you can do is, in that case, you do copy Sparc defaults dot template. Did you say?
.com.
Yeah, .conf is Sparc default .com. So that basically says I want to copy that template file and then call it just a conf file without a template. Make sense?
So is the default file essentially what you change if you want to alter something?
Yeah. So if you want to tell Sparc to have something configured, that's what it does. Okay. Okay. So I'm not going to actually show you what the Sparc default stuff is here right now, because I'm going to run it first and then show you how things are different. Okay, so all of you, we're going to now do PySpark -- master yarn deploy dash load client dash dash num dash executors. So for me, I'm gonna say 50, but you guys obviously don't have 50 things on your laptop, so you'll say something like 4. Okay. Actually, before I even talk about that, I should probably tell you what this is. Sorry, I'll come back to this. I'm sorry about this. Okay, so
Who was the person that was posted this question?
Yeah, I would take it easy.
Is that person be responsible?
I'll just leave it to the default.
what was that?
There's somebody posted a question. I don't know who they are. Yeah, I know it's like you.
Or did he keep it?
Yeah, they did.
So,
Yeah, you need to type the name that you want it to be. Does that make sense? When you copy a file, ***cat. Please remember, you need to copy and then define the name that it wants to be. I don't know, you're not an ****cat person. Okay, so let me give you a recap of the Sparc architecture. So Sparc has three things. It has driver, it has a cluster manager, and it has an executor, or it has executors. So I already talked about this. So driver master is the entry point of Sparc shell. It handles all kinds of like data distributions. It handles metadata. It handles like the plan. The DAC problem is being solved by the driver. The query optimization is being done by the driver. Everything kind of like, so the driver is more in charge of like moving things around rather than computing things. Executors, on the other hand, are given tasks to do. So like, I'm supposed to sort things. I'm supposed to multiply this by some gajillion numbers and give it to reducers or whatever it is. So executors are slaves. And the thing is, what I'm going to do next is I'm going to define the amount of memory I give to them. Okay? So I can define how much memory driver gets, and I can define how much memory the executor gets. And why does this matter? So why does this configuration matter? Because driver is actually more about moving files around. So it does a lot of input and output. So what that means is, if your operation involves a lot of moving files around, so like when you're using Sparc, you're going to be using this for a lot of tasks. You're going to be using it for machine learning. You're going to be using this for just straight up data transfers. You're going to use this for just straight up data preprocessing. So data preprocessing, if you think about the individual computations of data preprocessing, there's not much, right? Let's say I want to add 2 to every element. That's a data transformation. But does that actually involve heavy computations in terms of the actual data points? No, right? But it does involve a huge amount of data transfer. Does that make sense? In that case, you would try to give more memory to driver than executor. Versus if you're doing, let's say you're doing some kind of heavy gradient boosting tree algorithm that just does a lot of calculations, then you do something like put more memory into it. Okay, does that make sense? This tweaking is important because you have a limited number of memory. That's why Hadoop and Sparc requires you to at least have 8 gigabytes of RAM. And if you have less, well, you can't really do much. You're basically like splitting peas and like giving like 100 megabytes to that and like 200 megabytes to that. And like it's just, and then like our data set alone is 220 megabytes. So if you have a data set that's 220 megabytes and your driver memory is 1 gigabyte, it won't do. Just because when you're working with a data set, you're not always keeping the data set only in your system, right? You're going to be making copies, you're going to be making some kind of splits, you're going to be distributing them. So at any given time, there will be multiple copies in the system. So you want to make sure that the driver memory stays well above the actual object that you're operating. So, without further ado, I'm going to start PySparc. So, can everyone do CD? You do CD and nothing, you will go to your default directory, which is your home user folder. So, ta-da, you have all these stuff. Did you guys all download the Python notebook? My Python notebook, the Jupyter notebook? You guys all did? Okay.
What was the number of executors we have to do?
Oh, no, so I'm going to tell you now. Don't worry about it. every single thing that I just talked about now, I'm gonna do now.
So if your downloads folder is somewhere weird, find the file and then go there.
Yeah, so when you like download it from Slack, it will tell you like where it is. Try to select the option says, like after you download, select the option saying like open or show in folder, and it will tell you where it is.
Wait, do you want us to go to the green.csv file, where that is, or because that's in the downloads?
Oh, it's fine. So I only needed the green.csv to be my directory because I want to move it into the Hadoop directory. It doesn't matter where I am, as long as I start my Jupyter notebook above the directory or somewhere above the directory where you're at, I should be able to access it. Okay. Okay, so I'm going to type this: Sparc, master, yarn, deploy mode, client. I'm going to say num, executors. For you guys, 4 or 5. 5 is maximum. So don't go above that. I'm going to say, or usually your computer will, or Spark will stop you and just do 4. Like it will just do the maximum amount it can. So I'm going to do 50. I'm going to define driver memory. So notice the pattern. Everything that I define as a configuration starts with a double dash, and every space between the configuration name is a dash. Okay. So driver memory, I'm going to say 10 gigabytes. You guys don't have 10 gigabytes, don't do that.
Driver.
Oh, driver, sorry. Sorry.
Wait, so what do we do?
So, since you're going to have 4 executors and one of them going to be driver, if you give everything else 1 gigabyte or 2 gigabytes and give your driver memory something like, oh, sorry, that's not a good idea. Let's do 2 gigabytes for driver. Does that make sense for you guys? Yeah, 2 gigabytes, okay?
How many executors do you do?
What was that?
How many executors do you do?
4.
Oh, okay.
So your CPU in your laptop has usually 4 partitions or 4 logical cores or threads inside them. So you can at most run usually about 4 processes. So it's probably a good idea to do 4.
And how much memory do they say again? Sorry.
So if you, assuming you guys have 8, assuming you guys all have 8, 2, and then I'm gonna say executor memory 1.
So should I just double that by 16?
If you have 16, you're rich. Do whatever you want.
Got it.
5 gigabytes and like 2 for executor memory. And for you guys, 1 gigabyte. For me, I have about, to my knowledge, the servers have 330 gigabytes of RAM. So 320 divided by 50, so about 6. I'll give it like 5 gigabytes.
We give it 1, right?
Yes. 5 or 6 gigabytes. I'm just like doing like safety, kind of like hand wavy safety check in my brain. Like I don't want to use all the memory.
That's like, where is it, 5 per, that's per core?
Yeah. Okay, why are my ports already used?
It's probably you.
Yeah, probably. No, probably.
There's a better chance that
Okay, so yeah, I just turned it off and on again, but you guys have all this.
Nice question.
How many local hosts were we supposed to have? Shit, wait. Exception and thread. Okay. Shit, wait. Okay, exception thread. Sparc does not support any application options. If it says something like Sparc does not support any application options, it usually means you made a typo. Unfortunately.
Could you check the command, put the command into Slack just?
Yep.
for that?
Sparc. Master yarn.
Wait, you need it.
Plant. Num. Executors 1. Verse 4. Executor memory 1. or 2 gigabytes.
You said 1 for executor, 2 for driver.
Oh, right, driver. I'm old and my memory is failing. I'm sorry. I'm gonna be like I'm old. Okay, executor memory is 1 gigabyte. So say you gotta say G, okay? 1 G gigabyte. And I'm trying to think.
That's all.
Okay. Does that work for you, everyone? Cool. I'm gonna do this again. Oh, wow, I got my port back. Okay. Okay. So I'm gonna probably I'm gonna go to master 8888. For you guys, both of your green.csv and the IPython notebook is at downloads, right? So go to click on downloads and click on the IPython notebook that you just downloaded. For me, it's somewhere here.
Wait, if I want to open through another instance of Jupyter Notebook, is that fine, or should we open it through this?
What was that?
I opened like another Jupyter Notebook to have that example open, but should I open it through this?
Yeah, you should open it. So, disclaimer, there are ways of starting Sparc without typing all those commands. You can actually start PySpark in a Jupyter Notebook you have open already without doing all those commands. But for the sake of simplicity, and actually for the sake of the amount of, it's like doing things in the terminal actually gives you a lot of power and become almighty. And you can also do really bad things on the terminal if you're not used to doing things on the terminal, like removing things. Like there are no trash bins in Linux. Okay, it will always just delete, and then like we'll never find it again. So, but I'm advising you guys to use the terminal just because the terminal usually has a lot of control. Okay. Okay. So do you guys all see this? Oh, actually, you guys don't need to do this. I can actually delete. So the find Spark thing is for actually if you want to start Spark with it. But we decided that was not a good option because people have different problems. And we don't want to do that. Yes?
Yeah, so how do I actually open the notebook?
Yeah.
Because like after it opens up, after it starts PySpark, it just gives me those template files and everything. It's not like you switch out. Like after I open PySpark, it's just stuck on like the Spark defaults.com that particular directory. I can't like move out.
Oh yeah. So remember this in Jupyter. In Jupyter, you can only access up to the directory that you just entered. That you're at. If you started PySpark in a directory, you can't go above the directory. You can only go down. So that's why I told you to do CD with nothing. Then it just goes to the on. Yes. Everything I say has a purpose.
So really CD to wherever you download it.
Well, as long as you're above it.
Oh, yeah, that's true.
Yeah, so if I do CD to space, basically I just like come to the root node of everything, and then like I can do it wherever I want. So yeah, just like it's actually at first it's quite foreign because you're not used to thinking about directories in this fashion. You're more like used to like going to a folder icon and like somewhere and like going through the files. But this is actually quite, in a sense, like convenient. It's pretty clean, like the way you just move in and out of that. Okay. Okay, so run the first code. So automatically, once you start a notebook, or once you activate or start, or whatever verb you want to use, a notebook, you just started an application. So you remember that 8088 port that I told you guys to go to? Should now have an application running. You guys see that? Basically, I've been using the servers a lot. As you can see, there's like 10 of these. Yep.
How did you get the sample Python notebook into it? I missed that part.
It's on Slack.
Oh, okay.
Yep.
I can't get to that to show it. I don't have that to show by this.
Did you start Jupyter Notebook with PySpark, man? Yeah.
How do we run the charts?
Just wait.
You click on something, here's control enter.
But control enter is usually the command. But don't run anything yet. Don't run anything yet. Don't run anything yet. Don't get it greedy. Don't get, if you get greedy and it crashes, we can't do anything. All is lost. No, one does not. That's right. Simply. Okay, so this overview is quite important because I can see all the operations. I can see the summary statistics of what my system is doing. In this 8088 port, I should be able to see how much memory it's actually the Sparc program or the Hadoop program is running or eating up, how much is left, how many cores I'm using, and you should probably, hopefully, have all nodes. I think this is master. Why is this active nodes for? Oh, wow. Okay.
There's like nothing.
Oh,
Yeah,
that's
can we
right.
switch?
Sorry.
Did you figure it out?
For a moment, I thought.
You solve this, I'll solve that.
Okay. We have helper T cells running around helping you guys.
There's like no application, right? You know more about his issue.
Okay. So actually, active 4 nodes is fine because I have 4 servers. I forgot that this nodes means 4. Like nodes means servers, and I was like, oh my god, did I just like have everything dead? Okay, so you should have something called like active nodes 1, and you should have a 0 on the right side.
You need to stop. There are recurring issues. Can you show him?
Okay.
Yeah. There's like nothing running.
It's your Sparc.
Does anyone else have any other problems?
Okay, we'll take a quick like if you have problems.
No, you don't, I don't think Sparc is.
No, yeah. That's what
You're
no, you don't have to do that. Did you do the PySpark command?
Oh wait, I do have it.
Did you also do master yarn? Just control C.
Yeah, that's the same.
Not sure. Wait, who also has a problem that like their application is not showing up? You don't know. Why must your computer not comply? What was that?
They want at least 4 people with that issue.
Oh man.
Yeah.
Okay. Okay, how about this? Everything starting now. Everything starting now is actually me just explaining code. So, yeah, but I'll give you guys a little bit of time for like maybe 5 minutes. And I'll walk around and try to help. But like, let's take a 5-minute break for like, and I'll try to help people out. And then right after the 5-minute break, I'm gonna walk into the actual Sparc code. Okay? Everyone else is fine, right? Everyone else works. Okay. Saw the application.
You can do it on my ass.
Okay.
Oh, there it is.
Oh, you did it? What happened? Okay, if you.
Well, actually,
If you see this screen and that bottom part is empty, then day 1 needs to help you. If you have any other issue, then maybe.
Yeah, look confused, and I'll go help you. What's up?
If everything is
Wait.
fine.
No, it works.
Wait, we found someone with that disease who got a cure. So.
So it seems like when I run it with the deployment client, it doesn't show up. If I ran it now, it shows up.
Okay. Wait, so for those of you who didn't have the thing show up, try to omit the client part. So do delete the deploy mode. It seems to work for some people. I don't know why that works. Because we are running on Yarn client. So.
Is there like no place you can read more about the theory like, other than the documentation?
Actually, the documentation is pretty good. But I'm going to tell you the theory actually. Due to the early parts of this lecture, like the third lecture being,
Okay, who else had that issue?
Oh, that was fine.
like I'm gonna go a little fast on the code part, but it's like really easy to read. What really matters is how you optimize your operations. Okay? So the actual code doesn't usually change. It's usually the techniques you use that change to configure that.
So I'm noticing that Sparc has like already built in ML stuff and everything, right? So are you only like can you only use the built-in ML stuff, or like are you allowed to define like your own way to use Sparc?
You can define user-defined functions, but it's kind of limited the way you can use it. Because like obviously Sparc isn't like your normal pandas or NumPy operation. It's like working in a set way. But if you want to write your own stuff, you could fork the Sparc GitHub and like become a Sparc developer. I actually have the Sparc GitHub fork, but I've never touched that. So I don't want to touch it. I don't want to touch it.
So what exactly is a MapReduce? Like, I know it converts it, but like what, in terms of like an actual example, what would it be?
What do you mean by MapReduce?
MapReduce.
Day one. The solution to that problem is typos. Oh, never mind. Forget that. Well, at least it was there.
So it was your typo?
No, it was like missing deployment of the client.
Well, no, you want me to delete that.
Oh, wait, what?
No, because it worked for him. Okay. Different cases.
I thought it did. Doesn't seem like it actually.
Okay.
Oh yeah.
Okay. So we're probably going to start very soon again.
Yeah, so what exactly is MapReduce? Like you take it.
MapReduce is just you break down a task into parallelizable operations.
Yeah.
You feed it into the mappers. The reducer is just consolidated.
This is without deployment.
It's that.
Oh, so the reducer stream just collect the data.
Not just collect. It's consolidate.
Okay, because the way.
If it's a count, you add the counts. If it's a sort, you resort.
I have a question about configuration. So I've actually got 8 cores. Would it be better to have more executors and just allocate less memory, or just have 4 executors and give it like a KP?
That's actually something that I might go into. Like, in terms of like number of cores, how many cores to define, how much memory.
Solve the issue, please.
So we have
I see.
3 cores.
Okay, everyone else is good? Show me a chart. Do you want to do it on my laptop? So I'm just like walking around like that. It works. It's just every time you need a password, you should be else.
I think you edited the yarn side XML. So can you go to the yarn side XML? I think you typed something and then it just like you left the typing. Wait, did you finish?
This is what you just didn't do the client mode, and then it took a little while, and then it started.
Because someone got rid of the client mode, it didn't work. I added it back in, and it didn't.
I think you just the wait.
It's just
The wait.
Like
yeah,
the kernel didn't start
It
for
took
like
2 minutes to start the kernel.
and so it wouldn't show up
Because
until
it couldn't find the kernel at first.
If I want, right? You can just keep it.
Is it like, what if it's because I have all of these?
I don't know.
Wait, are you just running the debug code? Is this a VM? You remember the two? Yeah. Let me see if they are the match.
Really?
Those.
It's the old Mac. Really? It's no other Macs, dude?
Yeah.
That's what it's called.
Probably not.
No, not the Mac. Okay, I'm gonna try to.
Because your thing works.
Yeah.
How did you fix that issue?
Or I can give it some.
Wait, it's because his password. We found.
No, I got it, but how would that be?
Okay. For some of you, so
So when he did the dollar sign, it just did.
Wait, so did you fix it? Did everyone fix it? Okay. At least for one person, the yarn site.xml was like mis-edited. That's
Is that only a factor if you use a deploy mode client? Or either way? Yeah, that's it.
okay, but I'll try to. Okay, so like at this point, you still gain a lot by just following along on what I'm telling you. So even if you're not actively doing the code.
Who has problems right now?
Who has problems right now? Like, who's got issues? Okay, so I can attend to you after. Okay, is that okay? Oh, the yarn site, like, she deleted it, but doesn't have the original, so I have to give it to her and just contact her. I can do it.
You want to do it now?
Because I might just not just for that. Like, notice. Wait. Alright, so I'm gonna continue. We're supposed to do it till 7:30, so I'm gonna kind of zoom through the code. It's actually not, the code actually isn't like, yeah, the code is actually quite simple. So what actually matters is really the way you tune it, the way you do things. So, okay, so you can all run all this, but I'm just gonna, it really doesn't matter what the code is doing too much. There's one part that matters that I'm gonna talk about, called partitions. But I'm just going to kind of scroll through what this is. For example, you should change the read.csv file's input to the directory that you actually have your green.csv at, which is probably something like tilde/downloads green.csv. So I read in the data set. I'm actually not going to even, I guess I can run it. I should run it. Okay. Tilde/, so I changed it back to what it was, but tilde/downloads, where your thing should be. Okay? And you should run it, yes. Try running it.
It works with the client, yeah. I just had to wait like 5 minutes.
And sometimes you just have to wait.
Or it started working after I tried to import
Okay.
a command.
Oh, once you did.
Wait, who has errors?
Right.
What does the error say?
It says an error occurred in the column.
Run buttons on the
It
top
says the
was-
format, it's not the right format.
Yeah.
You have to change it.
Yeah, I think it's the format.
It should be the path. So you have your file in the downloads folder.
Wait, do you want us to just run the cell or run the whole notebook?
No, it's a
Oh,
cell.
just a cell.
Okay, don't run the whole thing.
How do you
It'll take
how do you
forever.
run the cell, just the cell?
You
Control enter.
Control enter or shift enter?
Yeah.
Okay.
How do you get the tilde? How do you get the tilde out?
Oh.
Yeah.
You can also do, wait, so you can also do this. Home, username that you're using,
Oh, is it?
and then downloads. This works too.
But some of it
Yeah, it shipped that.
So remove the tilde, right? You said.
Yeah.
Okay, wait, sorry about the A, but like, it's not, the A doesn't exist. Okay, does that make sense?
It's still running. And there's a star in the
Free
thing that
browser.
it's still running. Also, you can hear that.
Are you using the hard
Does everyone, does it work again for everyone?
Hey, can you?
Does it have to be an HDFS or?
Wait, what's up?
Does that
I saw a hand. Yeah?
There's not an HTFS.
Yes, it has to be the HTMS. Oh, sorry. Whoa.
That's what I'm saying.
Oh my god, sorry. That's why. Okay. Sorry, so you were supposed to move it to demo, right?
Yeah.
Demo green.csv. I'm sorry. Try running that now. Does that work?
Wait,
That work?
Go back.
Yeah.
Okay.
Wait, leave it there.
Just like a second.
Stop.
So we can see this being run now in our
Run, standalone, it doesn't need to do that.
What was that? Speak up, speak up.
Sparc has its own file system that it
Yeah.
can use, like in case you're not like.
Just show
Yes, but like